So now let's talk about classes. Okay. If you have ever heard about Java or any other programming language, you would have heard at least once somebody mentioning about classes. Okay. Now let's really dive deep into what's a class? What does it do? The way I always explained to myself and my students what a class is, simply, I like to think of a class as a blueprint, very simple blueprint of something. Think of architects, people who create blueprints, people who make designs for homes and bridges and so forth, right? The architect, he creates those designs as a blueprint. He literally draws, of course, draws in a piece of paper or pieces of paper, and then hands it off to the designers, the builders or the engineers who can actually implement and build the thing that he or she has designed, has created, right? Has created as a blueprint. So that is the same concept here when we talk about classes, because the idea of object-oriented programming is the fact that we can create these little small pieces of code, small entities per se of code that can be reused. Okay, that we can extend, we can make it bigger, we can make it smaller, but using these entities, that's how we create bigger and scalable applications. Okay, so classes. Classes, think of classes as a blueprint to something, but in this case, since we're talking about this abstraction in Java, think of a class as a blueprint of objects. Now, you may say, well, objects as in objects in a physical world, like a piano or a lamp or a glove. Yes, that's exactly right. That's the idea anyway. But as you know by now, when we talk about programming, everything is more abstract. Okay, but the essence is still the same. In the real world, a class represents something that doesn't really quite exist as an object, as something that you can touch. Going back to that example that I gave you about the architect with the blueprints. A blueprint of a house is not a house. Can we agree on that? A blueprint of a house is not a house, but what's a house is what comes of that blueprint. So the blueprint is just a map. It's a blueprint. It's just a guide. It's just a model of what should become something that is palpable, something you can go touch, an actual object. So that's the same idea, okay? So classes are blueprints of objects, so are building blocks of objects. So we need the blueprint, we need the classes in order to create those objects, which we can then use and create many, many great things. So as in any other thing, if we talk about, abstractly speaking, if you talk about a class or an object which comes from classes, then you have to understand they need to have properties, just like anything in the real world. If you look, for instance, a good example would be a ball, right? If I just say something like a ball, you right away understand what a ball is. A ball is something that is round, something that probably bounces, right? That's the whole idea. Okay, so it has certain properties what make it something that we can touch, an object, as in real world object. Okay, so the same idea again goes back to when we talk about object-oriented programming, right? Okay, enough talking. So let's give a quick example here. So I created a new project called Intro Classes, and you can do the same. And what I want you to do is to open in this folder here, Intro Classes folder, and you will find this another folder inside called Source. So it's src, and inside of that we have this com.goholjava.com, and then inside of that we have main, which is this file, a Java file that I have it open here. Okay, so what we need to do is right click here under, remember, under this folder com.goholjava.com, or whichever name you gave here. So this is the package name. Right click, say new. We want a new Java class. What are we going to call this? Well, let's call this Java class ball. That's our blueprint here of ball. Now, going back, we said in the real world, a ball has to have certain properties. Okay? Going back to that example that I gave you about the architect. right? The architect, as he goes through the process of drawing and figuring things out, he's actually doing it, right? He says, for instance, he's putting together a blueprint for a house, right? He actually puts there properties of that house, okay? All of those things. So in this case too, we are building our blueprint, which is not an object yet. It's just a blueprint. It's just a cookie cutter. That's a good example. Think of a cookie cutter, right? When you're making cookies, you can go and buy a cookie cutter and you can make from that blueprint, which is the cookie cutter, you can go ahead and create multiple different versions of that cookie cutter, but an actual cookie, right? With those properties that that your cookie cutter has, round and heart-shaped or hexagonal, whatever shape your cookie cutter is, then that shape becomes an actual cookie once you start cutting it. That makes any sense. Okay, so now we're constructing our ball, our class, our blueprint. Okay, this is our blueprint. Not an object yet. Okay, so our blueprint needs to have properties, needs to have attributes, needs to have certain features, certain what we call here instance variables. Okay, these are properties. There's different names, right? Or instance variables. Essentially, we're saying, well, what properties does this blueprint has to have so that when we create the actual ball, then we can then make it with those specific specific properties. Well, the one property that is very important, we're going to go and say public. Okay, we'll talk a little bit more about that. Let's say public color, public string color. So what we're saying now, we're creating this property of type string, which is color. So this ball will have a color. What else can a ball have? Public string name. Okay, a ball could have a name. Could be football. It could be basketball. Could be hacky sack ball. Whatever else you want to name it. Okay. So there we go. So we have two. Let's give another one. Let's say public int. Let's call this one bounce rate. You know, how high can it bounce? Okay, just to alternate, to change things here. So we have three properties. We have color, we have name, we have bounce rate. So this blueprint here, ball, has color, has name, has bounce rate. But it also has to have certain behaviors. Because again, we are creating an actual blueprint of an actual thing, object, a real ball. So we also need to have behaviors. So these behaviors, I wrote like, in the United States, we just say behaviors, not with you. All right, these behaviors, we represent those behaviors by using methods or functions. So we can say public void. What's one behavior that a ball has? What does a ball do? It bounces. Bounce. And we can say system out that print ln bouncing. Okay, another behavior, we can say public void. What else does a ball do? A ball could deflate. Okay, system out that print ln deflating, something like that. What else can it do? Well, it can inflate. If it deflates, that means also inflates. So it's a void inflates. Actually, let's make this bounces, bounce, deflate. Let's say inflates. Something like that. Very simple. Let's go system out print ln, and where we say here inflating. All right. Now we have a blueprint of a ball. So this blueprint, obviously, it's not a real ball, right? So now we have to make the actual ball, the actual object. How do we do that? Well, we go back to our main here. We have to do what we call instantiating. We need to create that ball object, okay, in memory. So how do we do that? Simply, we start by calling, the syntax is we are creating a ball object from our ball blueprint here. So here we're going to say ball. There we go. It says right away that we have our class ball. So enter, we're going to name it something, just like we've been doing with our variables, right? So ball is the object, and then we're going to call this my ball. Now we are going to instantiate, to put some space in the memory, say, hey, this is what I'm doing here. I'm creating the actual ball from the ball blueprint. So we're going to say equal. We use this new keyword, so literally that means we are creating a new space in the memory where our object is going to live. Okay, now we're making the actual object from our class. I'm going to say new ball, like that. And my friends, this is what the entire Java library relies on. Objects. Objects and objects and objects. Classes and objects, okay? So now we have a handle. That means in the memory, we've created a ball object. My ball, we named it a my ball. So now we can access the properties of my ball and the behaviors to set things up. So now we can go ahead and say, my ball, check this out, you say dot, so you're trying to access behaviors and properties of my ball right? This is my ball object because it's an actual object now. We can say, for instance, color, we know it's a string, is equal to blue. We go ahead and say my ball again, dot, what else can we say? We're going to call name is basketball. Okay, again, my ball dot. So the dot notation means we taking our object, my ball, and say, hey, give us the properties, give everything about this ball that we can set or access. Okay, that's what we're doing. So dot, we are trying to access what that my ball, all of the my ball properties and behaviors. That's about it. Those are the properties that we have. What we have done here, we have set up our ball, my ball object. It's no longer a class because we now say new ball. We are creating an object of type ball. So check this out. Now if we say system.out.println and we pass in my ball color, save, look what's going to happen. Blue. Because we said my ball color of the object is going to be blue. If we go dot name and save, because look what's going to happen, basketball. So now we are accessing the properties that we set up here of this is my ball, and we are displaying it here. Look at that. Now, the coolest thing about this is that we created one my ball here, one object of type ball, one ball we created from our class. But the beauty is we can create as many balls as we want. Okay, so now here we can go ahead and create a ball. Okay, second ball is equal to new ball. Now we have another object of the same type, so we created a total different object. So we create a total different object that we can give different properties. So we can now say second ball dot name is equal to soccer ball. Okay. Again, the second ball dot color brown, like that. So this second ball and my ball are type of ball. So they all come from our ball class here. However, they can have different properties. So this is a very interesting and fun way to start understanding this object-oriented programming thing so that we are able to do a lot more with our code. Alright, so I will see you next video where we will continue with this subject of classes and objects. Alright, I'll see you in the next video.